All right, guys. So, on your warm-up, I was walking around as I was checking the homework. I was looking at pretty much everybody copied down the 2 dimensions. Because you're going to need to have that there as your support. And then it says, show your work to solve the answer. When you explain, use the elements of the math writing rubric. So, just quickly share with your partner the elements of the math writing rubric. Go. So, out of the 4 elements, I mean, there's obviously a couple elements that have a few different pieces. But out of the 4 elements, which element is probably considered the one that we need to work on the most? The bottom one, right? This showing. So by having these 2 shapes already explained on your paper, you're already showing. So, rectangles A, B, C, D, this one, E, F, G are similar. So right there we know some things. What's one thing we know? Yeah? Corresponding sides which have a scale factor involved because they're similar. Okay, what else?
Sides.
Okay, and corresponding angles. Angle measures are equal. Angle measures do not change with similar figures. Okay, and it's the same shape. So find the side length of AD. So we're looking to solve that right there. Talk to your partner. Which one's the original? Which one is the new?
New one is ABCD because it has all the scale. There's a missing value.
So we almost all identified. Here's the side I'm looking for. This is my original. So I know I'm looking for a scale factor going this way. And most of you said, well, the new one is, this ABC is the new one because it has the unknown. This is where I'm trying to solve for X or question mark. The original already has 2 sides, and these sides correspond with sides on the ABC. So if I go to scale factor, because that's the first step to finding an unknown side, Connor. Scale factor equals new side divided by original. So talk to your partner. What would you be dividing here? Go. So I know I'm going to go 9 divided by 3. Because these 2 sides are the 2 corresponding sides, I get a scale factor of 3. Now that I have my scale factor.
Yeah, it's supposed to be 3 divided by 9.
Whoops, you're right. You are. Yeah, it can't be 3 because it's too big. That'd be getting bigger. Thank you. Just checking to make sure you guys are paying attention. Okay, so hold on. So now that I have a scale factor 1/3 going this way, my scale factor going that way is 3. It's the reciprocal of 1/3. So now that I have my scale factor of 1/3, I can come over here. And I can use this algorithm, which is scale factor times original side equals new side. So I have to find corresponding sides. I'm trying to find X. So what corresponds with X is 6.75. Take my scale factor of 1/3 and I multiply it by 6.75, and you should have gotten an answer of 2.25 centimeters. So you say yes, Cam. What does that 2.25 equal?
In a fraction?
No. What does it equal?
Oh, the missing side length.
Missing side length of AD. So AD side equals 2.25 2.25. Now that is just the mathematical portion of it. So when it says explain how you found your length, you're going to need to do some of the explaining about how to find a scale factor, as well as how to use that algorithm right there, which is scale factor times original side equals new side. Yeah.
I did everything backwards and I still got 2.25.
Whoa. So what? Did you do what I did at the beginning? You said it was a scale factor of 3?
Yeah.
Okay. And what did you multiply? You obviously did not multiply that by 3. You divided this by 3.
Let's see. So I did. Oh yeah, I know what I did. So I took. So I don't know why I did this, but I put the number that was 3 times as small as that was.
As this.
Yeah. So then.
And then you got the 2.25.
2.25.
Yep. Yep. Some of you might have been able to see right off the bat that obviously if there's a scale factor of 3 going this way, there's a scale factor of 1/3 going that way, so what's 1/3 of that? You might have been able to see that. Definitely. Okay. Questions about this? Make sure you use the rubric. Okay. Missing work, I sent that email out last week. That will go in as a 0 now if you have not handed it in to me. Check your email often and dig into your grades. Okay. You know, if you're missing something from this past week, please get it to me. Older stuff, it's gone. Friday school tomorrow, 9:30 to 11:30. You guys that are playing basketball, it's a great opportunity. I don't know, what time is your training tomorrow?
We start at 7:30 in the morning.
Okay, so basically you get done at
I
9:30.
always go to Friday school.
So go to Friday school, watch videos. You got the YouTube videos, this one right here, and subscribe.
No.
You want to be that cool, Tatiana. Yeah, you do. So go ahead and subscribe, watch the videos. Okay. Make sure that you check your warm up and exit tickets. Look at your grades, dig deep in your grades, do all that stuff. Couple things that you grabbed at the door, and this is what Friday school could be super helpful. Miss Harris is here tomorrow.
Oh, yes, I love Miss.
And Miss Harris is like guru of math. So great opportunity to come. Okay? To have some help. Have help. Miss Harris is way too smart to do your work for you. This is your unit review. We have a unit test on Thursday next week. This is due Wednesday.
This student's already off.
Okay, so
Next week?
yeah, this is due Wednesday next week. So Friday school, Ashton, I know you guys got a busy basketball schedule next week. I think you have 2 games.
Yeah.
Okay? So hey, get this done at Friday school. The other one thing that you grabbed. Okay, so the unit review is going to be really helpful, obviously, for the unit test. Is it similar? Yes. Is it exact? Not even close, but it's similar. If you can do a good job on this, chances are you're going to do a good job on the unit test. This is homework for Tuesday. A great opportunity, Friday school. So listen, I would start some of it, for sure, over the weekend. On Monday, we're going to have what we call a fishbowl. We haven't done one yet. Really fun.
What do you do? What is it?
You look at a goldfish while they swim around. It's cool, Schmitty.
That sounds really fun.
It's really cool. Schmitty likes watching goldfish. I'm Schmitty. No. Fishbowl. So a third of you will be in a circle in the middle of the room. Okay? And then 2/3 of you will be around. So then what we're going to do, you notice how many questions there are? How many questions?
3.
So, one group that's in the middle, okay, will discuss one of the questions. And I'm going to give you guys about 3 to 4 minutes. At the end of the 3-4 minutes, we switch, new group comes in. Next group discusses the next question. So it should give you lots of ideas. It won't be enough time to try to write and listen. You won't be able to do that. But if you write first, you can definitely check some of your work as they're discussing. That's what I'm saying. You might want to have some of that prepared. And then obviously the last group, we discussed the last question. Pretty fun. I did it a couple times last year. Actually, I only did it once. Didn't work out very well with that class. So, today we're talking about using similar nested triangles. Okay, you know what a similar triangle is? So what does nested mean, you think? Yeah.
Yeah, it's a bird. Like tweet. The triangle that. Hold on.
All right, I'm going to move on. Hold on. Nested means it is inside of a triangle. And it shares a common angle. So let's say that's one big triangle, and we're going to call this A, B, C.
Abaca.
And then Abaca. It's a good band. Abaca is a great band. And then this would be a nested triangle inside. So a nested triangle, they share one angle in common. And then the other angle is a 90-degree angle. So that means all angles end up being the same. And if all angles are the same, it is a similar triangle. So you can use a nested triangle to help figure out the other triangle. Eli.
I have a question about Friday school. So if you go, you can stay for the whole school.
No. Not unless Friday school's been assigned.
Unless you're mean or like behind.
You can just like bail anytime you want. You can be like,
You have to stay there.
Okay, Connor.
that was on the summer class. There was a message.
It happens.
In 31. Any questions? Yeah, there was.
Stop. Don't talk to me.
All right. So today we're talking about similar nested triangles, how we use those in the real world. So I'm going to talk, when we get to that, I'll show you kind of like what my brother does as a civil engineer. Okay, so please turn to page 69. All right. So, right off the bat, I want you to talk to your partner about how you found the length of RS using CA. Go. Original new.
That's what I did. Copy.
Yeah.
I did this What time did you go? They're gonna see my hand.
All right. So, come back here. So, Addie, I have my new. This is my new triangle. This big one. The reason why is it's asking me to find RS. So this is the triangle that has the unknown. So it's going to go on the top. Okay, and then this is my original. So it's going to go on the bottom as the denominator. So I picked two corresponding sides that have values. 8 corresponds with 4. They're corresponding. 8 over 4, I get 2. Choose my scale factor. I want to find this side length here. So I multiply my scale factor by 3 and I get 6. So that's kind of the easy part. You guys did a great job with B. We're going to tackle E. So start talking to your partner about E on page 69.
I said angle A is equal to x and y.
Start talking.
C and B.
Okay, so the first thing you guys that you might not have known, complementary angles are angles that equal 90 degrees when I add them up. So angle X and Y, those are complementary. Because when I add them, they're going to equal 90. So it says find two additional pairs of complementary angles in triangles ABC and QRS. Now, yeah.
It would be C and B and R and Q because both of those, you know, those equal 80 because it's a right triangle, so it already, 90 because it's a right triangle, so it already has 90 degrees and 90 plus 90 equals 180.
So here I have a 90 degree, right? So if that's 90, hold on. If this is 90 here, what's my total value of all my angles? 180. So that must mean that angle C plus angle B must also equal 90. Because what's 90 plus 90? 180. So C and B must be complementary. Okay, they are definitely going to equal 90 degrees. What's another one? Yeah.
I wasn't here for that
Nope.
question. I was actually.
What's another one, Otis? We know C and B are complementary because C plus B plus A equals 180. So let's go over here. We have a right angle right here, R and Q. So angle R plus angle Q also equals 90 because if this is 90, this plus that must also equal 90 as well because 90 plus 90 is 180. Okay, let's go back now because I felt like this should have been first. Talk to your partner about D.
Okay.
So this is a hard question, guys. So, I don't know what these angles are here yet.
No.
Okay? But I do know y plus x equals 90. I know that S and A are equal, C and R are equal. So if this is 80, I have to actually, in order to start figuring this out, I have to figure out what this degree is right here. So if I went and asked you, what is T angle, this whole angle right here, how much does that equal?
180.
180. So if I know part of it's 80, what's the other part? 100. So now we can actually start doing something because now this is 100 here. So if this is 100, what might this angle, do you think this over here is 45 and 45? No. It can't be because this here isn't 90 and 90. If this was 90 and 90, that would be 45 and that would be 45. But it's not.
No,
So what could it be that would equal 90? Yeah?
45, 45.
What do you think, Callie?
40.
40 and 50. Now if you look at it, which one's bigger, which one's smaller?
X is smaller.
Okay, so we're going to put this as 40. Let's just say that's 40, and then we're going to work through, see if it works. 100 plus 40 is
140.
140. So what would make that one over here?
50.
45.
Wait, no, isn't that one smaller?
Remember, what is TSQ angles all going to equal? 180. So if I have 100 plus 40, what would this be?
40.
Okay, let's see. Now if Q is 40, that's 40. So now what's 90 plus 40? 130. So what would C be? 50. Because 90 plus 50 plus 40 is going to equal 180. So if this is 50, what else is 50? R. R is 50. So now, hold on. What is 50 plus 80? 130. So what is Y?
50.
And 50 plus 40 equals 90. So that's difficult. Angle R is 50. That's a hard question. All right, put away your homework. Please go to today's sheet. Okay. I'm going to give you a little scaffolding, and then I'm going to let you try to talk to your partner about these two things. We're going to do a little bit of work. Here's the scaffolding. Here I have a big triangle, and then I have a nested triangle inside of it. The nested triangle is here. Now, I'm just going to tell you that one thing I like to do when I have nested triangles, I like to pull it out so it becomes separate. It just makes it easier to visualize sometimes. So this is 80 feet. This is 120 feet. Okay? What? Yep. So now that I have that, I'm just going to take this out. So now I'm going to highlight this one so it kind of sticks out more. And I know that this is 140 feet. And that's 80 feet. And that's 120 feet. So basically now, how would I solve to figure out? I take the nested triangle out. Remember, that nested triangle only works if there's a 90 degree here, which there is. And there's a 90 degree here. So because this is nested in this, are they similar or are they not similar?
They're similar.
They're similar.
Yeah.
And so now that I know that they're similar, can I figure out how far it is from there to there?
Yes. Yeah.
Okay. Go ahead and do it. Work with your partner.
Oh no.
Yep. Talk, you two.
Dang it. You can find the length by finding the scale factor of the top, since that's 140, and the other one is 80. Then once you find the scale factor, you can scale the side angle up, and then you'll find the...
Oh, it's right there.
Because I know that the 90 degree, it can't share that one. It has to share either this one.
It would scale this side length up.
Write your math on your paper.
And then, hold on. Okay, 180, 120. Oh,
You got to do this. You got to figure out the scale factor from the nested to the big.
Four.
And then you have to do that.
240. I think this side length. I think it's 240. I hope it's 240. No.
Why are you doing 120 plus 120? That's not going to tell you how far it is from here to here.
It's going to tell you the side.
Ooh.
You guys, in
That's how
order
your
to
side
figure
length.
how long that side is, you have to do this. You got to figure out the scale factor. Because you know that this and this is similar.
It is scale factor. What are they doing?
Busted.
What?
Nothing.
Um,
Oh, it has a microphone. Oh.
So what's the scale factor you're trying to get? How are you getting it?
you would no.
So you're saying
You would
this is my new and that's my original?
it's hold on.
It's the other way around.
No.
Because I'm trying to find this. So that's my new. That's my original.
Wait.
I'm trying to find that way.
It's wait. Okay, so that's 2. It's the answer is 2. No, it's 3. It's I think.
The scale factor is 2.
Oh. All right. Here we go. Which is my new and which is my original? Because I have to, if I'm trying to find a side length, I need to first know the scale factor because that's part of this equation. So, which is my new and which is my original? Ashton.
Your new would be the top.
The big one?
Yeah.
Okay. Because why?
Because it has all the measurements.
Remember, my new, this would be my new because I'm trying to find how far this is. So this is an unknown of x. So this is my original because I know 2 measurements and I'm not trying to solve an unknown over here. So that really matters because I have to follow this where I take a new side that corresponds with an original side. So which 2 sides correspond? Where I have values? Otis.
Correspond.
Which sides correspond so I can figure out a scale factor?
Well, you can find out the scale factor because you could use the top
Yep.
and then
The top of what?
the top of the triangle. The original triangle.
Okay. Okay, so that would be my denominator.
And then 140 would be.
And 140 would be my numerator. Because these correspond. So if I know how big the scale factor, or what's the scale factor from here to here, then I'm going to be able to know the scale factor from here to there. So that becomes 14 over 8, which then I can reduce again. That becomes 7/4. That's my scale factor, right? 7/4. So 7/4 means that this big triangle is 7/4 the size of this. And that almost makes sense because what's 80 doubled? 160. Is that close to 160? Yeah. So that makes sense because this is almost 2. That makes sense. So now what do I do, Braden, with this 7/4?
Wouldn't you multiply it by 80? I mean by the 120?
Yes, because I know it's 7/4. 7/4 times 80 gives me this. So 7/4 times 120 is going to give me that. So I go 7 over 1 times 7/4 times 120. What is that, 840? So that's 840 over 4. I can reduce that. How many times 4 go into 8? 4 goes into 4? 210. What's that 210 mean? That is how far this side is. 210. So, how are the angles in the smaller triangle related to the angles in the big triangle? Talk to your partner.
What was the question?
So I was listening to Peyton. Peyton said they're exactly the same. First of all, in a nested triangle, they're going to share a common angle. And then your other one, this one is 90. And that's 90. So that's the same. So it must be that this angle is also the same. Because this plus that's going to equal 180. And if that's 90 and that's 90, and they share that, this must also be equal. So all the angles are the same. Can you use a reptile to show the smaller triangle is similar to the right triangle? Could I do that with this one right here? Could I reptile the nested triangle?
Well, with like.
Some of you.
Because
Why?
the bottom part, it won't work.
So if I took this and I doubled it, would that fit?
No.
Okay. Could I flip it?
No. Yeah. No, you couldn't. It would stick out.
Oh, yeah, you could.
What's this side going to equal if I reptile this? 160, because it's going to be double. Is that double? No. So I couldn't reptile this in here. Because this side's going to be double, and we already know the scale factor is not 2. If it was 2, could I reptile it? Yeah, I could. If it was 2. Because then it's going to be a little bit longer and a little bit wider. And I could, but the scale factor is not 2 right now. So, as an engineer, you would do stuff like this, where you're trying to find how far something is this way. You can't quite measure it because of certain obstacles like trees or whatever. I can take a small scale, and then I can scale it up. It's pretty cool. Okay, especially like if you have buildings or trees and you can't go through them, right? This is what they do. They're like, okay, well, I know this length. And then they say, well, I know this and I know that. Boom. And they can find how far it is without measuring. It's really neat. Okay, today you're going to be working on 3.4, but you're going to start on B. Okay, we don't have a ton of time because we did most of the work already.
Whoa,
Okay, go for it.
Okay, we're working with Oh, but I want to be on video. Hey, put it on mine.
Okay, Cam. Talk, read the questions.
Okay, so number B. Describe the relationship between the perimeter of the smaller triangle and the perimeter of the larger triangle. Okay,
Describe the relationship between the small triangle
I
and
just read
the
that.
perimeter of the larger triangle.
Right, okay. Anyways,
Well.
yes, so that means you have to, like, there's the smaller triangle right there, you see that?
Yeah.
Reptile.
Yes, I see the small triangle. Cam.
So we have to describe the relationship. They're similar. Okay, so anyway,
The similar. I
letter
mean.
B. No, number B.
Number B.
Number B.
Number B.
Okay, so
Okay.
yes, you're gonna do. Yeah.
Okay, we're on number B. Describe. I already read it. Okay.
Are similar. They're similar.
Well, they're similar.
Similar
Yeah.
figures.
Yeah. That word I can't speak.
All right, so is that all it says? Just describe the relationship between the perimeter. Oh, the perimeter. They're similar figures. So
The perimeter is similar.
means that the perimeters are not going to be the same, but they are going. That the perimeters are not going to be the same because one is smaller.
They're not the same, but
Can you say, yeah? Can
they
you
have
figure
similar
out
angles.
Can you figure out the perimeter, how much bigger it's going to be
Yeah.
by using the,
And scale factor.
yep. That should be included in there, and you should say how much bigger it will be.
Okay.
Because
Can we have to figure out how much bigger it's gonna be?
I know. Is bigger by. Okay, anyways. What is the perimeter of the original big triangle?
The original big
The
triangle.
orange. We'll call it the orange.
The orange. Why?
The orange. Okay, so.
Why though?
Anyway, so that means it'd be. I don't know. 140 feet. 140. I mean. 140.
Okay. You find the scale factor since I found it on the last one.
Okay. The scale factor is
140 over 35, and you have to divide them.
not the scale. Are you asking for the scale factor?
Yes, Cam. That is not what I just said. What do you do, Cam? Counting it doesn't make a difference.
Okay, it's something.
You have to divide 140 by 30.
Okay, why?
140 by 35.
Well, I know.
Yep, you knew that.
Why don't you do it?
Because I did the other one.
Because you're not smart enough. You can, right?
I can, but I don't want
I'm
to.
trying to coax her into it.
So it
Okay,
says,
fine.
yeah, it says
Just do the problem.
and measure the segment.
Yeah, Cam, just do the
Why?
problem.
I mean, ladies first. You know what they say? Be a gentleman.
Oh, well, I don't care. So,
Well, you should still.
What order do you
I
think?
mean, does that thing
How do you
sound?
think
Is YouTube hearing everything that we're saying? Sorry.
no, Cam, it's not listening to us. Yeah, no, duh, it is.
Oh, so there's.
Does it matter?
Anyways, so
Skill
What
factor
order do you think
is.
you put it in? What?
I spelled that wrong. Cam.
what?
So if you were going to make a triangle, that
Okay,
So-
Cam, find the skill
It'd
factor.
be
You need to divide
four,
140 by.
four.
Do the math.
Yeah.
What can you multiply 35 by to get to
Because I'm
140?
not good at dividing.
Go get the calculator.
What's it? 145, 30.
It's 140 and 35, Cam. 5.
because if he puts this here, now his nested triangle would be like this.
Yeah, it is 4. The scale factor is 4, but why are you trying to find the scale factor? We have to find the perimeter.
We have to find this side, Cam.
Yeah.
We have to find the long side.
It's 4. That's 4.
So we multiply 30 by 4.
Okay, so 30 by 4, that's not 15. It's more like 7.5
7.
equals 7.5.
30 times 4.
No, 30 divided by 4.
You want to multiply 30 by 4, Cam.
Okay, that equals.
No, I'll do
It's
it.
120. It's 120.
Because he's kind of
Cam, I'm
lining
doing the
up
math.
T1 to
And you're
T2.
correct, it is
And
120.
he's like, okay,
Ah,
this is
yeah, alright.
fine. Now I got to put it in T2.
Diz.
Put that in. And he
YouTube. Yes, Cam. If you're not established the fact that it's YouTube. Okay, so now we're finding the perimeter. The perimeter. So what's 120 times?
I'll be right there.
What have I just been hit with?
I dropped my pencil.
It's not saying
Explosive.
give me the perimeter. It's asking you what do you know
Okay,
about
I'll
the
do
perimeter.
120 times 2 and you'll do 140 times 2.
140 times 2?
Yes, Cam.
So think of like
140 times 2.
what
is
corresponds with perimeter.
280.
Really?
Okay. 9, 10, 11, 12.
Yeah, you're in this mindset.
4,
of, well, I
5.
can't figure out that side. But you-
520 is the perimeter.
Alright, so.
Do you know how much bigger this is? So how much bigger the perimeter going to be?
Alright, nice. We're geniuses. Fine, that's B. Now we move on to.
That's what they're looking for.
What are you doing?
I don't know, rapping like a god. Right, so rap like gods every day. Okay, so number C. I know, right?
No, number C. You mean letter C, right?
What? No, number C. Okay, number C. The diagram on the previous page shows
C is a
3
number.
stakes and 2 trees. In
Science.
what order do the things do? I'm not gonna read.
Okay, I'll read it.
Okay,
The
good.
diagram of the previous page shows 3 stakes and 2 trees. Wow.
Nice.
In what order do you think Daryl, Angie, and Tanya located key points and measured the segments and angles? Explain your reasoning.
Stake 3. Because math. Because math.
How to do math, children?
Hey, you guys, what's up?
Cam.
Do you think they hear that?
I don't know.
You think that thing picks up sound?
I don't know.
Well, I guess we'll find out when we see the video.
This is an ASMR.
It's asking you.
Yeah. Okay, so
You're gonna tip your chair over and you're gonna fall over your desk. I'm
on
gonna laugh
YouTube,
so
it'll
hard.
go on a try not to laugh video if it's on YouTube.
Or no, because only school kids. I hope he flips his chair.
Okay,
Okay,
the diagram on the previous page.
I already read it.
Okay, then what do we do? The weird thing is I don't like doing math. I like doing homework, but not math.
The big triangle.
Yeah, that makes sense. That makes sense.
Cans
I've
don't
been
make
doing a lot of
sense.
homework lately.
Wow, you're doing everyone the grades homework? Take mine too.
What?
If you're gonna do everyone's homework, you should take mine.
What do you want me to do? Start doing your homework?
No.
I should learn how to get like a girlfriend to do my homework for me. When I get a girlfriend, I'm gonna be like, hey, honey, I need you to give me my homework for me.
You realize this is going on YouTube, right?
You guys didn't hear
All right, guys. If you can go ahead, put away your.
Erase everything.
Put away your learning. Austin. Just do what I ask, please. It'd be one thing if I saw you doing what I asked, but you have a hard time sometimes. You know what I'm saying? Okay. All right. Justin, what? What? You have 2 things of homework. You have plenty, right? You have the review packet and the reflection. All right. So you have those 2 things to get ready. So your reflection is your homework for the weekend and the review. You can do both. Reviews due Tuesday. You're going to pass in the reflection. Wednesday we're going to go over and I will check the review. Yeah, we didn't give enough time for the partner reflection, so just write partner reflection. On Monday, we will do the fishbowl activity. That will give you a lot of scaffolding for your exit ticket. Remember, class doesn't end until 2 o'clock. Okay. I need in here your warm-up and exit tickets.
Hey guys, subscribe to the
Make sure you have your... Whoops, you're right. Wrong one. Hold it. Where did I put it? Oh, I put it up top. Here it is. Make sure your name, name is on it.
Oh yeah.